Today's lab is entitled Mystery Powders. And what we have are 9 powders that are commonly found in the house. So they're conveniently labeled 1, 2, 3. 4 is this short one. I tried to write on it, but it's kind of erased. 5, 6, 7, 8, and 1. So we have 9 instances. And now a negative here. Oh, you don't want to write this. You have normal ones. A negative here is that because we're using household substances, these tests aren't super definitive, which leads to some frustrations. But we're going to be doing tests to determine what these chemicals are. I remember high school chemistry, college chemistry, doing these kinds of things, and honestly, not being as frustrated as I am with this lab. I don't want to give you guys a bad feeling before we start, but I want you to know you're going to have to deal with some frustration. Don't say, I must be doing things wrong. Do your best. We will have some understanding of a few errors because it's going to happen. So what we're going to be doing is chemical tests and looking for physical changes that indicate a chemical change. Hey, look, there's a stopper right here. Let me draw the stopper right here. We're going to be looking for physical changes that indicate a chemical change. So we have a number of reagents here: tincture of iodine, phenolphthalein, white vinegar, rubbing alcohol, sodium hydroxide. We also have water. So you'll each get a thing of water. Yay, this is deionized water. Safe to drink. At the same time, I don't want to drink it.
Why? He did it.
Yeah, but he's an idiot. I don't think These other things you don't want to stick in your mouth. This is why you're not supposed to have food in here, right? These things here, like if you take this.
But everything's safe.
If you take this here and you get a little bit in your mouth, you're gonna get sick.
Oh, I was thinking of the powders.
Well, even those. I mean, if you look at the list of what they are, we have cornstarch. We eat that. Yeah, white chalk. I'm not very fond of that. It's calcium carbonate. It is just going to go through me, but well, as far as I know, it's H3BO3. I don't know. Table sugar, table salt. Well, we're fine with eating those. Baking soda, sure, we put that in our food. Epsom salts. Yeah, I don't think anyone eats that, do they? Probably wouldn't hurt you. Washing soda, like calcium carbonate, probably just go through you. Plaster of Paris. Yeah, that would probably make a big lump in your stomach and cause you all kinds of distress. So you don't want to eat these things. And of more concern are things like, you don't want to get this phenolphthalein in you. So we want to be careful. So for safety, we are all going to wear our goggles. You don't have to wear them yet, but when you start playing with the chemicals. And yeah, we have test tubes. I have 3 test tubes for each of you. So they're just in here. I'm not going to go pass them out. You only really need 1, maybe 2, depending on how you do things. So it's not a big deal. Notice that you have sinks by your places, so you can clean stuff out at your sinks. Since these are all household chemicals, I believe it's perfectly safe to wash them down the sink just like you would any other household chemical. Okay, the first thing that you have to do, and you need to do this before you start doing your tests, is create a flow chart of the tests you're going to take. And it tells you to make your first test the water test. And then some of them will be soluble, some will be insoluble. You got to appreciate that. That's not my typo. Right? It would be kind of ridiculous if you had soluble versus soluble. And this one here is honestly the one that causes me the most frustration. How do I know if it's soluble or not? So let me just go through an example. So I'm going to take this, and it says put a pea size. In my interpretation, a pea size is going to be a couple millimeters in here. And so I take a spatula. Make sure the spatula is clean. You don't want cross-contamination. Now, we don't have to be all kinds of rigorous with our cleaning, but we want to have it roughly clean. So I'll grab this, clean it just to make sure that I'm not cross-contaminating, and choose a sample for me. Choose a number between 1 and 9.
8.
8 it is. You don't know what 8 is, you just know that it's sample 8. So I'm going to take this, and you'll notice that all of these substances are chosen so they're white powders, although some powders are more granular than others. As it says in the lab guide, don't eat these. Some, will be sweet, like sugar. Sugar's kind of sweet. Some will be, burning in your mouth, so just don't do it. Now I'm going to put water in up to, see where my fingers are there? About 2/3 full of water. So I put it 2/3 full of water.
Oh.
That's just break.
Yes, it just broke. If you had this kind of strength, you would be impressed, right? Okay, now I filled it too high, mostly because I was focusing on I just broke the bottle. So I'm just going to let a little out. Now, what I want to do is see if it's dissolving or not. So I look at the level here, and then I do this for like a minute. I go, the lab guy says slap it. Kim said slap it, just sit here and tinkle it with your fingers. Yeah, okay, so we can go like this. We want to be like Bryson. Be careful, you don't want to throw it across the room and break it. And what you're looking for is that level going down over time.
I don't think this is dissolving.
And this is the toughest one to determine if it's dissolving or not. And so, if you are not sure,
You know what it is?
I don't know what it is now. If you are not sure what it is, Nathan has a cheat sheet and he can kind of help you cheat on this first test. Make sure you give it the old college try first. Don't just say, oh, this one? Give it the old try. Okay, so I look at this and I think it's gone down. So I think it's dissolved a little. Now I have a sheet of paper which I printed a bunch, and as soon as Nathan gets here, I'm going to have him go get them for us, that you're going to fill out. And hopefully, the ones I printed out are going to be right size paper. Microsoft, it makes things print the wrong size. 8.5 sheet of paper, it didn't fit. Okay, so you're going to take this, and since this is sample 8, for the water test, I'm going to put soluble because that's what I believe I got for my result. After you get that checked with Nathan, okay? Before you move on, just give it the old college try. Don't just, put stuff in and say, I got soluble. Nathan! Check for it.
But doesn't it
Here,
say,
all over the table.
It's just water.
doesn't it say it's insoluble and soluble here?
You don't know which one's which, though. That's what we're trying to find.
Cornstarch and insoluble.
Yes. But which one is sample 8?
Oh, that's what, okay, that's what you're saying.
So what we're doing,
So
what
we're
we're trying to do is
determining
define
by
which one.
this,
Yeah,
which,
that's right.
okay.
So that's why we're filling out this table. You're going to take the results you get from this table and match it to those results. Yes.
So we're making this thing on like the back of the lab?
Yes, make that flow chart on that blank sheet. So you need to do the flow chart first because you need to know what to do second. Now I'll tell you, if it's soluble, your second test should be put it in hot water. So I give you one more than they give you. If it's soluble, your next one's going to be put it in hot water. So I thought this was soluble. I think it went down a little bit. I hold it in this so I don't have to put my hand in hot water. I'm going to put it here in the hot water, and I'm going to make the water a little hotter now. I cooled it down because we were between work prep and lab time. And I need to leave it here for at least a minute. I want that water to get really hot. And so it's kind of boring as a teacher to stand here for a minute holding something. So we'll talk about, what are you guys doing for spring break?
Going home.
Where's home?
Ohio.
What are you doing, Amber?
Going to my house for the last time.
Well, enjoy it. Your house is not that far from ours, is it?
It's like 2 hours is what he said.
2 hours.
So you guys are down by Colorado Springs and I live in Idaho Springs. So there's like that much difference.
Do you snow ski? No. Neither does everyone else in our group. Only Joel and I snow ski.
I've never done anything.
Then you should come skiing with us at least. We're gonna go on Thursday when it has $30 lift tickets
Okay.
at Ski Cooper.
So,
Which is-
okay.
Ski Cooper is close to Copper Mountain, I think. Never been there. Do you know where Ski Cooper is?
I know what Copper Mountain is.
What are you doing, Bryson?
Going home,
Which is?
Kansas City.
Yeah. Not very far. Place to get snowed in it. How about you, Hosanna? Go to his home again. Okay, now that we've spent enough time, now we'll see, did it dissolve anymore? So I look at it now it's kind of hot, so I'm going to be a little careful here. And I would say, I think it looks like it dissolved a little more. And so I would mark for this test, it dissolved a little more in the hot water. And then in my flow chart, I check, what's the next thing I do if it dissolves a little more? So let's just look here and say, okay, so our test number 1 was in water, did it dissolve or not? And I said, if it dissolves, test number 2 should be put in hot water. So if you put it in hot water, if it dissolved, it's one of the bottom 6. If you put it in hot water, you have greater solubility for everything except for no effect on table salt and only a slight increase in boric acid. Isn't that great? Slight increase. How do I know what slight is? Actually, all things considered, can you go up to the copy machine upstairs and grab the forms? Oh, you need to, did you check in yet?
Not yet.
Yeah, let you check in first. You know which one it is, right? Which D? It's the one on the side without the tab. Yeah. Okay, so I have this now marked for the second test, and I need to determine what the third test is. Superior solubility.
Oh, yeah.
I now have it's table sugar, or baking soda, or Epsom salt, or washing soda. And so then you'll have in your flow chart what your next experiment will be. So I'm just going to make up the next experiment.
Test the pH.
Okay, test the pH is what I was going to make up. Good thinking. So to test the pH, I have the phenolphthalein. And I'm just going to put a little drop of phenolphthalein in. Notice I don't have to change anything. I can use the same water for everything except for if I have to do the alcohol test. So I'm going to put a few drops of phenolphthalein in.
Is that the stuff you don't want to understand?
This is stuff you don't want to eat.
Oh.
So, skin's not the worst thing. Did it change color? No. If it turns light pink or medium pink, you have a reaction that tells you which one it is.
Epsom salt, table sugar, or table salt.
Okay, so we narrowed it down to that, and then we'll have our next test to narrow it further. So you can see the importance of doing your flow chart first so you know what test to do next. Now, there's more than one way to design the flow chart, and you might find a method that has less tests required than the one that I came up with. But each one of you, and work as a team, so I don't expect Hosanna to have a different one than Bryson. But the two of you need to come up with your flow chart and have it on there. Show us the flow chart before you start doing the experiment. Because if you don't have your flow chart figured out, you're going to have a hard time getting anywhere. Okay, so then you go through these experiments, and Nathan will be in here to keep you on the straight and narrow as you do these. I'll be in my office in case there's any problems. I've been great. We saw a lot of stuff in your box. And get some more as we go through the day, maybe. And hopefully by the end of the day, you'll have some idea of how we can identify chemicals and what the physical changes are that go along with these chemical changes. So,
Okay, wait, what on earth?
I don't know. I honestly don't know.
It's not because
Now, when you're done with the sample, nice.
Did you break that too?
No,
A little bit?
no,
a little bit.
A little bit?
not at all.
Oh,
When you're done with the sample, just pour the sink because we have things that are all nice, simple, as far as I know. I mean, sometimes it's hard to get it out, especially here where I heat it up. A little more water pressure is what I use before to get it out. So I'm making a mess, but we gotta get it out somehow. Yeah, doing really well. Probably I need to heat up.
Cleaner?
I don't. I'm not a chemist.
Go to the chemistry lab.
Yeah.
They steal stuff from you.
Yeah, well, this is all provided by them. Yeah. Okay, maybe you guys didn't want it to do that, but I did. Okay, well, I'm having a horrible time getting this out, but such is fine. As they say in French, say that. Let's go over what the tests are to make sure you know what they are and don't make a mistake in those tests. So the first one, the solubility in water, is the one we started with. So you just put your little pea size, are those correct now, these terms? Yay, that's the way they're supposed to be. So those are the ones you're going to fill out. The pea size, then put the water in, see if it dissolves or not. And Nathan, I told them to give it the old college try, to sit there, and tap it for a minute and watch and see if it dissolves, and to then say if it dissolved or not, and then to check with you. And that you will tell them by looking at your picture I had you take what it should be for their sample. That way, they'll get the first test right. Because the first test is so easy to get wrong. But they're not just going to pour water and say, did that dissolve? Right? They have to give it the old try and make a measurement that they think is correct, and then check it with you. Okay? The second test that's listed here is tincture of iodine. So in this case, any unknown that is insoluble in water. Clearly you're not using this with one of the ones that you determined dissolve. You leave it in the water. You don't take it out of the water or do a new sample. Just leave it in there. Put a few drops of that tincture of iodine. It will either turn deep blue or it'll turn brown. So it's pretty clear which way it went. Now, because it changes color, this is probably a good one to, save for later, if you can. The phenolphthalein test, you saw me do it. You'll have two that turn pink. They turn pink by different amounts. If you get to the end and you're like, well, these are the two that turn pink, I'm not sure which is which, then just make two, you've got 3 test tubes, so take 2 of them and mix each one, put your phenolphthalein and say which one turned pinker. That way you can differentiate them. The white vinegar test, this one here, you add a few drops to your unknown, and if it has carbonate, CO3, then it will produce bubbles, carbon dioxide. This is part of the standard geologist kit. I mean, you guys have seen geologists, right? They got their total nerd kit, little hand microscope. They sit there, a little magnifying glass. And they should also have their little bottle of acid. And what's the purpose of the acid? It's to determine if something is, by the way, see, these glasses work. Water here, water not in my eye. The acid is to test if you have a carbonate. They put the acid on the rock. If it bubbles, carbonate it. If it doesn't bubble, no carbonate. So it's a quick way to distinguish between those, and it's a standard practice in geology. So you're just going to have your stuff in water, whether it's dissolved or not. You put a few drops of the vinegar in, and if you see bubbles forming and bubbling up, then you know it's one of the things that has carbonate in it, either calcium carbonate or sodium carbonate. The sodium hydroxide test, this one here actually is a little interesting. The sodium hydroxide test, I made sure I went over this with Nathan before class here. When you put it in, it will either turn cloudy because you formed a little precipitate, or it won't turn cloudy. So you're looking for if it turned cloudy or not. And my experience is the clouds didn't fall. Precipitate, I expect it to fall. We say it's snowing. Well, this year it just stayed suspended, but it became cloudy because I had little crystals that formed there in the liquid. So when you do that sodium hydroxide test, that's what you're looking for. If it doesn't get cloudy, negative. If it gets cloudy, then it's positive. And then the hot water test, you saw me do that. You put it in the hot water. How long are you going to leave in the hot water? For at least a minute, yeah. And then you're checking to see, did it dissolve more? So you have to make sure you registered how much was it dissolved before I put it in, how much is it dissolved when I brought it out. And you might give it a few taps just to, The rubbing alcohol test, that one you start fresh. That's the only one where you dump it out and start fresh. And you can dump out just the water and leave your powder in there, and then fill it almost to the top with isopropyl alcohol, which I hope this is the right concentration. I don't think you pay as much attention it is. So you fill that one up and you're testing to see if it's soluble in the alcohol. So those are our tests. So do we have any questions?
For the flow chart, like, how do you want it to look like it is on the first page?
Your flow chart should look, yes. So your flow chart should start with 1, water. If it's soluble, then you go to, and the next one I said was hot water. Hot water was test number 6. And you actually have 3 outcomes for the hot water test. And then for each one, you're going to have, and so you go on. And of course, if it was insoluble, then you're going to choose what test you're going to do there, and then branch on the outcomes there. So you want to choose your tests so that you have the fewest amount of tests, right? Because nobody wants to take a whole day and do every single one of these tests on every single one of these items, right? You could, but that's just going to take you more time. We want to take less time by being as wise as we can. So yeah, you need to have it out. So at the bottom, like hot water. Hot water, you have 3 outcomes, right? And so let's look at those 3 outcomes just so I can, and I did right here. Oh, actually, I take that back. I did phenolphthalein before I did the hot water. Since I said hot water, I'm going to change that to phenolphthalein here. Phenolphthalein, I'm not going to write the rest of it. So we had medium pink, light pink, and new color. And so if it was medium pink, then it's going to be washing soda. And if it's light, then it's going to be baking soda. No color, well, you have a number of things and you continue on. And so you should have your test go on until you have, so this is the one that's hot water. Greater solubility. This is slight solubility, and this one's no change. And no change, you know that it's table salt. Slight change, you know it's boric acid. Greater solubility, you're going to have to do another test. And then you have 2 outcomes there, and you know what it is based on those outcomes.
What's the other test?
You have to determine. And then you have your tests over on this side that you have to do as well. So I do have at least half of your table completed for you at this point. But your flow chart here, that's the actual thinking part of the lab. Is how you're going to do this most efficiently. And there are other ways you might have come up with a different order on the soluble side than what I did, and it might be more efficient than mine for all I know. That's what I came up with. All right. Go for it.
Do we each have to make a flow chart, or can I make?
Well, you're making it together, but you should each draw it. Right, so you're thinking together, but you're drawing your own.
Table salt. Okay, one of those table salt. One of those sugar. Is this table sugar?
The one that's SA is salt. So the first one is the one that was salt. Once SU was sugar. And you can tell just by looking at the data that they give you,
What
right?
was this in the end? Is that what you were?
Well, it's nil actually.
Oh,
Where's, so which test is that?
hot
I'm
water.
gonna get number one.
If you turn that over,
No solubility.
if you turn that over, the hot water, you have greater, slight, no.
Okay, so no.
What are the ones that is that an N?
Wait, you gotta finish your flow chart first. Why? Because you have to do your flow chart first before you start testing, otherwise you end up doing the wrong test at the wrong time. What was your question, Amber?
Under the three, you have three boxes. The last one is no color, but what are the other two?
One is light and one is medium.
That's an L?
That is an L.
I thought that was a C.
How am I supposed to find
Oops.